Okie dokes. Today we're going to be looking at functions, function tables, input, output, equations, graphs, everything. Everything. We're going to put it all together. We're going to start on page 43. So also, if you have a ruler, some sort of straight edge, I'm using this ruler. Again, you don't need anything to measure with, you just need the edge. So, because we're going to be doing some graphs, so we're going to have to be drawing some straight lines. So if you have like a book or if you do have a ruler, that'd be perfect. Or even a yardstick might be extreme, but that also could work. Okay. We're going to start it off by just looking at a completed graph. You can see this is linear here. Let's take a look at the information we have here. We have number of hours, and we have number of miles. Now, remember, here, this is the x-axis, always the x-axis. So what goes in the x-axis is the input, always. The y-axis is up here. That goes vertically. What goes in the y-axis is always the output. Always. Okay, so the independent variable, that's going to be the input, will be number of hours. So we're going to let, I don't know, h equal number of hours. So this is showing that we can start with a graph and pull information out of the graph to help us write an equation. The first things we can pull out are the variables, and the first one's the input. This is the number of miles. That's going to be the output. Also, the total, also called the dependent variable. So we're going to let, m equal number of miles. Here comes the equation. Here it comes. The dependent variable, or the total, will always go by itself. So we're going to start with m equals, well, how are we going to get, this should be an s, by the way, how are we going to get from the hours to the miles? 150, 2, 100, 3, 150, 4, 200. It looks like these are going up by 50 each time. So I think if we multiply the number of hours by 50, you get the output. 2 times 50 is 100. 3 times 50 is 150. So m equals 50 times whatever h is, hours. So again, we can go from a graph to an equation by pulling out the information the graph gives us. We also could have made a table with this if we wanted to, but we didn't have to, so we didn't. All right, let's check out our first example here. We're going to make a graph for this. It says each week, Quentin earns $30. If he saves this money, create a graph that shows the total amount of money Quentin has saved from weeks 1 to week 8. Write an equation that represents the relationship between the number of weeks that Quentin has saved his money and the total amount of money he's saved. Okay, starting off, let's start with that total. That total is going to be the dependent variable. That's the money he saved, s. So the dependent variable is going to be let s equal total money saved, something like that. Okay? The other variable will be the input, or the independent variable. That's going on. Well, I guess that would be w, number of weeks. Let w equal number of weeks. Here's the equation. S is the total. So s is going to go by itself. And to get the total, we're going to multiply the number of weeks by how much he earns per week, which is $30. So we're going to let s equal 30 times w. Now we'll fill out our input, output. Our input's going to be our independent variable. That's number of weeks. And that's going to be w. Total money saved. That's going to be the output, s. And we're looking at weeks 1 through 8. Well, you know what? I'm actually going to put 0 in there as well. So 0, 1, 2, 3, 4, 5, 6, 7. We'll put 8 right there. All right, let's do it. So after 0 weeks, Quentin will earn $0. 1 week, 30 times 1 is 30. 2 weeks, 60. 3 weeks, 90. It's going up by 30. Every week he's earning 30 more. 120, 150, 180, 210, 240. There it is. All right, let's make this graph. So just like I did last time, I'm actually going to just darken these lines in slightly. You don't have to do this, but it just kind of helps show the axes a little bit better. Okay. I think that worked out okay. All right, so we got to think about which goes where. This is the x-axis. This is where the input goes. So, probably can't see that. This is where the input goes. This is going to be number of weeks. Number of weeks. Now, I might have to move that down slightly because I have to put my numbers there. I was too hasty. Number of weeks. Always start with 0 here. So we're going to start with 0. Now the weeks are going up by 1. If you look at the table, the weeks are just going up by 1. So the number of weeks, I'm going to have those go up by 1. 1, 2, 3, 4, 5, 6, 7. 8's going to be all the way down there. Okay. The total number saved is going up by 30, it looks like. So that's what we're going to do as well. We'll go up by 30. 0, 30, 60, 90. We're just kind of using the numbers from the table, in fact. 150, 180, 210, 240. And we got to label this. This is going to be total money saved. That's the y-axis. This is going to be the output. We'll call that y. Okay. All right, now that we've labeled it, set it up, let's plot our points. 0 weeks, $0. Right there. 1 week is going to be $30. 2 weeks, $60. You can see this is going up by 30 each time, just like the equation. 3 weeks, $90. 4 weeks, and it should be linear because this is a linear function. So it should make a straight line. 6 is going to be 180. 7 is going to be 210. 8 is going to be 240. So perfect. So this is not really that good. There you go. All right. Let's connect it. Make a little line here. Nice. Make sure you have an arrowhead at the end of your line there. And then the last thing we're going to do is just name it. We'll call this Quentin's savings, perhaps. There it is. What a graph. So again, labels, we got our numbers labeled, we got our axes labeled, we got our line, we got our points plotted, we got our title. A lot goes into making a graph, especially when you're making it from scratch. All right, here we go. Let's go to page 44. Let's go to page 44. Here it is. Here it is. Zoe's collecting books to donate. She started with 3 and collects 2 more each week. She is using the equation. Oh, they give us the equation. Look at that. B equals 2 times W plus 3. Where B is the total number of books. Look at that. They're giving us the variables. Let B equal total. That's the dependent variable. It is the total number of books. And W is the number of weeks. It's really straightforward here. Number of weeks. So they gave us a lot of information very clearly in this problem. Name the independent, dependent ones. Did it. Then create a graph to represent how many books Zoe has collected when W is 5 or less. 5 or less. So that includes 5. So with the information they gave us, we can already set up our table, and then we can set up our graph. Can't wait. So independent variable, that's going to be the number of weeks. That's going to be W. B is number of books. That's the output. I should put total in there. And that's B. Now it says when W is 5 or less, so 5 or less weeks. I'm starting with 0. 0, 1, 2, 3, 4, 5. All right, now you got to be real careful with this, because after 0 weeks, you might think she has 0 books, but she started with 3. So 0 times 2 is 0 plus 3. She's got 3 books because she already had 3 to begin with to donate. And then each week after that, she collects 2 more each week. 1 times 2 is 2 plus 3 is 5. 2 times 2 is 4 plus 3 is 7. 2 times 3 is 6 plus 3 is 9. So these are going up by 2 each time because she's collecting 2 per week. 4 times 2 is 8 plus 3 is 11. 5 times 2 is 10 plus 3 is 13. All right, let's turn to our graph here. Let's do a little labeling first. So we'll label the x-axis. I'm just going to do a little line, a little arrowhead here. This is going to be number of weeks. That's our input. And this will be number of books. Now we got to look at our numbers here. All right, so number of weeks is just going up by 1. So usually the input's really easy to label on here because we start with 0 and then you just kind of go up by 1s. I can't think of an example where you'll do that. This does not, the x-axis right here for the input doesn't just go up by 1. The number of books is a little different story here. Now you got to be real careful here. You got to be real careful because you don't want to just use these numbers, because if you go 0, 3, 5, 7, these numbers, the scale has to go up by the same amount each time. So if we went 0, 3, 5, that's going up by 3, then going up by 2. You can't do that in a graph like this. So we have to go up by the same amount each time, even if it's not the numbers necessarily in the table. We have to make sure to fit them. But we can't really go up by these numbers because it'd be going up by 3 and then by 2s. So let's try some numbers out. 10 would be way too high. If we went up by 10, 20, I mean, the greatest number is 13. So going up by 10 is not a good idea. Let's try 5 would be too many as well. Let's try 2. Let's see if 2 would work. We have to make sure to fit 13 in there. 2, 4, 6, 8, 10, 12, 14. 2 would be perfect. So even though none of these numbers are actually our outputs, the scale here is going up by the same number each time. It's going up by 2. 2, 4, 6, 8, 10, 12, 14. Again, this is, put an arrowhead here. This is the y-axis. All right, let's start graphing points here. So 0 weeks, 3 books. So 0 weeks, she's already got 3 books. That's going right there. 0 weeks, 3 books. 1 week, 5 books. It's going to be between 4 and 6. 2 weeks, it says 7. So again, it looks linear to me. This should be going up by the same amount each time. 3, 9, 4, 11, 5, 13. 5, 13 is going to be right there. Take your straight edge, whatever you're using, line them up. There you go. Put a little arrowhead at the end of that. Last thing, we have to label this thing. Let's call this one, I don't know, Zoe's Books. Zoe's Books. All right, we're going to do 2 more. We're going to do 2 more here. This one here is about Eliana. This one's a little different. They don't give us the equation here. However, we can still figure it out. Eliana plans to visit the fair. She must pay $5 to enter the fairgrounds and an additional $3 per ride. We've seen something like that before. Write an equation to show the relationship between R number of rides, T, total cost. Well, I'm going to start with that T. That's the dependent variable. That's the output. That's the total. Let T equal total cost. The other one would obviously be the independent variable. That's going to be R. R equal number of rides. Okay, you got to think about this one for a second. She must pay $5 to enter, an additional $3 per ride. All right. So T is the total cost. It's going to go by itself. Well, the number of rides will vary. That's why it's a variable. But to find the cost of the number of how much it'll cost for the ride, she'll pay $3 per ride. So to find the cost of the rides, we'll do $3 times R. But she also has to pay that $5 just to get in. Just to get in. So she pays that only once. So we're going to add 5 to that. That's the one-time fee, just like the one about the taxi. We've done one like the fare before as well. So here's our input. That's going to be number of rides. R. And total cost. T. Let's see, how many rides does she go on? Rode 5 rides of less? Probably should be or less. 5 rides or less. So I'm going to start at 0. So she rides 0 rides. 1, 2, 3, 4, 5. Well, if she rides 0 rides, again, you might be thinking, well, she's got to pay $0. However, she's got to pay $5 just to get in. 3 times 0 is 0, plus 5 is just 5. 3 times 1 is 3, plus 5 is 8. 3 times 2 is 6, plus 5 is 11. So it's going up by 3 each time, because each time she's riding another ride. So 11 plus 3 is 14. 14 plus 3 is 17. 17 plus 3 is 20. Now we can do our graph. Can't wait. It's going to be a good one. All right, so independent variable, that's the x-axis. That's going to be number of rides. I'll put my little arrowheads here, label that x. It's number of rides. And again, those go up by ones. So in the table, 0, 1, 2, 3, 4, 5, those go up by 1, so we can just label those 0, 1, 2, 3, 4, 5. Now this is just like the last one. We can't just take the numbers from the table and put them on here, because we did 0, 5, 8, 11. It would go up by 5, then by 3. We can't do that. We have to go by the same number each time. And this is going to be total cost. Let me just label that here. Total cost. All right, this is going to be the y-axis. I'm just going to make that line here. That's the y-axis. All right, let's see. Would 2 work again? Because if 2 works, that would be great. If we can go up by 2. 2, 4, 6, 8, 10, 12, 14, 16, 18. No, doesn't work because we have to go up to 20. Let's try 4. 4, 8, 12, 16, 20. It's kind of like too compressed. Maybe 3 might work. 0, 3, 6, 9, 12, 15, 18, 21. Oh, okay. 3 might be our best bet. I wish we could do 2, but we'll do 3. So 3, 6, 9. Again, even though these aren't the numbers necessarily on our graph, we want to go up by the same amount each time. That's called the scale. We want to scale it up the same. We want the scale to go up by the same number each time. Let's graph. This one might be a little trickier. So 0, 5. So if she rides 0 rides, she's still got to pay $5 to get in. So 5 would be like right around there, closer to 6. 1 ride is $8. 1 ride is $8. So 1, 8. Again, that's a little bit below the 9. There it is. 2 is $11. So it looks like all of these are going to be just a little bit below the next number because it's going up by 3. because it's $3 each ride, so that makes sense. 3 is going to be $14, a little bit below 15. 4 is 17, so it's kind of going in the same spot, which is great because that definitely means it's going to be linear. 5 is going to be $20. Nice. Okay, let's connect those dots here. Nice. It's all fitting together well. All right, so I don't know. The title might be like Eliana's Trip to the Fair. I like that. Trip to the fair. It's really the amount of money she spent on rides, but or actually her total cost of the trip, but it looks linear to me. We're going to do one more on page 45. Let's see, which one will we do? Let's do the one about Caleb. Caleb started saving money in a cookie jar. He started with $25. He added $10 to the amount each week. Write an equation where W is the number of weeks and T is the total amount in the account. Well, let's start with that T. Let's start with that total. That's going to be our dependent variable. Let T equal total amount or money saved. And we're going to let W, which is the independent variable, let W equal number of weeks. Okie dokie. So the equation, it says he started with $25. He adds $10 per week. So we'll start with our dependent variable, which is T. It's our total. $10 per week would be $10 times W, right? Because he's getting $10 per week. Plus, he started with the $25. So plus 25. Okay, so now we can make our little table here. Input is going to be number of weeks. That's going to be W. Total amount saved. That's going to be T. We're doing less than 6 weeks. So that's 5, 4, 3, 2, 1, and 0. So we'll start with 0, 1, 2, 3, 4, 5. So after 0 weeks, you might think he has $0. However, he's already starting with $25. So 0 times 10 would be 0, plus 25 would be 25. 1 times 10 is 10, plus 25 is 35. So each week, again, is going to go up by 10. So from here, the next week we'll have 45, because each week he's saving $10. Then 55. Then 65. Then 75. All right, let's hop into that graph here. So we'll label the input first. That's the number of weeks that goes on the x-axis, or the horizontal axis. And those go up by ones, like usual. 0, 1, 2, 3, 4, 5. We don't need to go up to 6 because we're not graphing 6, so it's okay to leave that blank. And then this is going to be the y-axis. Now you'd think we can go up by 5s because these are all end in 5, but that wouldn't work out because we'd only get to like 5, 10, 15, 20, 25, 30, 35, 40. So we have to get to 75 or more. So maybe 10. Well, first let's label it. I'm thinking 10 though. 10 might be good. It's the total money saved. Let's try 10. Let's try 10. 10, 20, 30, 40, 50, 60, 70. Perfect. So again, we can't just go 0, 25, 35 because that's going up by 25, then by 10. It has to go by the same amount each time. So let's go up by 10. 10, 20, 30, 40, 50, 60, 70, 80. All right, here we go. Let's plot our points. 0 is going to be $25 because after 0 weeks, remember he started with that $25, so he'll still have some money in there. 1, 35, which is right between 30 and 40. 2 is 45, between 40 and 50. 3 is 55, between 50 and 60. 4 is 65, between 60 and 70. And 5 would be 75 right there. All right, now we can do our little line. And what shall we call this graph? Caleb's savings, perhaps? That might be an appropriate title for this beautiful graph. We'll call it Caleb's savings. And again, it's linear, just like all the other ones. All right, so it's good practice. If you want to try the one below it about Kevin, that might be a good idea. But we're going to stop here today. If you have any questions for me, let me know. If not, have a great day, and I will see you soon. Bye-bye.